Hello, so in today's class we will look at what is called pigeonhole principle, and we'll see the what is pigeonhole principle, and then we'll see what is generalized pigeonhole principle, and after that we'll be seeing concept of Ramsey numbers. So in the Ramsey numbers we'll be using this pigeonhole principle. Okay, so let us begin with what is a simple meaning of pigeonhole principle. So suppose we have three pigeons and we are having two compartments. Okay, so the pigeon has to go to these two compartments. So there are the number of pigeons is 3 and the number of compartments is 2. So pigeons compartments occupy ചെയ്യും. അതെങ്ങനെ occupy ചെയ്താലും there will be a compartment which contains at least 2 pigeons. ഒന്നെങ്കിൽ എല്ലാ pigeonലും ഒരു കമ്പാർട്ട്മെന്റ് വരാം, അല്ലെങ്കിൽ ഒരു pigeon ഒറ്റയ്ക്ക്. അങ്ങനെയാണെങ്കിൽ ബാക്കി കമ്പാർട്ട്മെന്റിൽ in the second compartment there will be 2 pigeons. So whatever is the way in which your pigeons occupy the compartments, there will be at least 2 pigeons in one compartment. So that is the simplest idea of the pigeonhole principle. അപ്പോൾ നമുക്ക് n+1 objects n boxes ഉണ്ടെങ്കിൽ there will be at least one box which contains, there is a box which contains at least 2 objects. So that is the simplest idea of pigeonhole principle. So if 3 pigeons are to be put into 2 compartments, then one of the compartments will accommodate at least 2 pigeons. So that is the more simpler version of the pigeonhole principle, or that can be thought of as a layman version of pigeonhole principle. Now let us look at the proper definition of the pigeonhole principle. So the pigeonhole principle states that let k and n be any two positive numbers and if at least kn+1 objects are to be distributed among n boxes, then one of the boxes must contain at least k+1 objects. In particular, if at least n+1 objects are to be put into n boxes, Then one of the boxes must contain at least 2 objects. So that is the general statement of the pigeonhole principle. So let k and n be any two positive integers. So if at least k plus n objects are to be distributed among n boxes, then one of the boxes must contain at least k plus 1 objects. In particular, if at least n plus 1 objects are to be put into n boxes, then one of the boxes must contain at least 2 objects. So now let us look at the proof for the pigeonhole principle. Now proof is by contradiction. So we need to prove that there is a box which contains at least k plus 1 objects. So if so the proof is using contradiction. So if no boxes contain at least no boxes contain k plus 1 objects, then every box contains at most the k plus 1 object in, so every box contains at most k objects. This implies, so this means the total number of objects will be equal to kn, which is a contradiction. So therefore there must be a box which contains at least k plus 1 objects. So this implies that total number of objects put into the boxes is at most kn, so which is a contradiction. Since there are total kn plus 1 objects, so therefore one of the boxes contains at least k plus 1 objects. So this is the proof for the pigeonhole principle. So let us look at a few examples where we apply pigeonhole principle. So the first example is, among any group of 7 people, there must be at least 4 of the same sex. So let us take 7 people as 7 objects, and let us consider the boxes to be the male and female. Okay, so we treat 7 people as 7 objects and boxes as male and female. So now 7 can be written as, so 7 is the number of objects, so that is 7 can be written as, so you can write as 2 into 3 plus 1. So this is the number of objects. So here you have n equal to 2 and k is equal to 3. So by the pigeonhole principle, so there is a box which contains at least k plus 1 objects. So therefore there is a box which contains at least k plus 1, so that is equal to 4 objects. So that implies by pigeonhole principle, so there must be at least 4 people of same sex. And the next example is among a group of 13 people, there must be at least 2 people whose birthday are in the same month. So there are 13 people, or that is you have 13 objects and you need 13 objects in a നമുക്ക് monthsലാണ് distribute ചെയ്യേണ്ടത്. So there will be 12 months are there, so there are 12 boxes. So what you have here is 13 objects and 12 boxes. So there must be a box which contains at least 2 objects. So that gives the result. So you have 13 equal to 12 into 1 plus 1. So here k will be equal to 1 and n is equal to, n is the number of boxes, so n is equal to 12. So by pigeonhole principle, so there is a box which contains at least k plus 1, so that is equal to 2 objects. So that implies there are 2 people with birthday on same. There are at least 2 people with birthday on the same month. So that is the second example. So now let us look at one more problem. So the next problem is show that for any set of 10 points chosen within a square whose sides are of length 3 units, there are 2 points in the set whose distance apart is at most root 2. So you are having a square where the dimension is 3, and now you are choosing 10 points in the square. The square nulil 10 point choose cheyana. So now we need to show that there are 2 points such that their distance is at most root 2. So that is what we need to prove.